Unit 10 Circles Exam Review, questions number 11 through 18. These are our more advanced questions in the sense that they are multi-step and require us to do a few calculations before we actually end up with our answer. So let's just jump straight into it. We're finding the measure of angle or arc indicated. Here we are looking for the measure of arc WUV. So here's arc WUV going from point W to point V through point U. So how much is this arc? Well, let's start with our given information. We are actually given in a central angle of 63 degrees. Well, this central angle is related to this arc that it intercepts, and they are in fact equal. So that means that this arc here is also 63 degrees. Well, we can recall from our discussions of circles that there are 360 degrees in a circle all the way around. So that means that if I wanted to figure out this unknown piece, I can simply do 360 degrees minus my 63 degrees that are known, and that will give me my missing arc, and in this case 297 degrees. Okay. Central arc is equal to the arc that intercepts, 360 degrees in a total circle. 360 minus my known 63 gives me my leftovers. Question number 2. We are trying to find angle CBR, so we are trying to find this angle here, and we note that this is a inscribed angle, or more importantly that the angle sits on the circle. So let's just draw this out a little bit. If I were to continue this angle out from here, that means that this is an inscribed angle, and if I were to be able to find this arc, I would know that this angle is half of the arc measure. So once again, an inscribed angle is half the arc measure. I go back to the first drawing that we've seen, where if I have an angle on the circle, if I told you that this was 25 degrees, you would tell me that this was 50. Right, we have that half relationship happening. So if this was 50, you would be able to say, oh, I divide it by 2 and give me 25. That's exactly the same scenario we have happening here if we ignore this line and this line. So how could I figure out this arc? Well, I know that this arc is 68, and I know that this arc is 70, and once again, we know that there are 360 degrees in a circle. So to find my missing information, 360 degrees minus 68 minus 70 gives me an angle measure of 222 degrees. So this is 222 degrees. And to find my angle measure is equal to 1/2 of whatever the arc is. So in this case, it is 1/2 of that 222. So that means my angle CBR is in fact equal to 111 degrees. This one again is hard. See the forest through the trees. See the inscribed angle through the quadrilateral. Once again, if I was able to just go ahead and get rid of this line and just focus on the angle that's happening, this angle is sitting on the circle, which means that it is half the measure of the arc that it intercepts. So if I figure this out, 222, it is going to be half this measurement of, so it's answer to 111. Okay. This next one, once again, is dealing with an inscribed angle, or an angle that's on the circle right here. This 43 degrees is on the circle. So what I'm going to do is I'm going to extend this all the way out to the arc that it intercepts. So this measure right here, this arc that's listed there, is equal to 2 times whatever the angle measure is of the inscribed angle, or the angle that's on the circle. So again, you may see that's very similar to what we wrote here. Angle is equal to half the arc, or the arc is equal to 2 times the angle. So in this case, it is just 2 times 43 degrees, which means that my arc measure is going to be 86 degrees. So right here, I have an arc measure of 86. Well, how does that arc relate to this angle here? Well, this is a central angle, and we know that the angle is equal to the arc for a central angle. So we know that the arc and angle measures are equal on a central angle. So that means then the angle in question, angle CYW, is just equal to also 86 degrees. Okay. Question number 14. Once again, we are seeing that we have an angle measure that lies on the circle. So that means that if I extend this angle out, the arc that it intercepts is equal to twice the angle measure. So once again, the arc is equal to 2 times my angle measure, working out. So that means that this is equal to 2 times my 50 degrees, or my arc is equal to 100 degrees. So this is 100 degrees. Well, what are we actually trying to find here? Let's not lose the point of that. We're trying to find arc KJ, and I actually put an X mark, question mark on it, an unknown value, so that way we knew we were finding this arc. Well, going back, we know that there are 360 degrees inside of a circle. So if I took this 360 degrees minus my 100 degrees that I just found, I will be able to figure out what my remaining arc length is going to, arc measurement is going to be. So that's going to be 260 degrees for arc KJ. Just a quick note on this, these first 4 problems, 3 of them dealt with angle measures 360 degrees in a circle, 360 degrees in a circle, 360 degrees in a circle. Three of them dealt with inscribed angles, angles that actually touch on the circle, 12, 13, and 14. And 2 of them actually dealt with central angles, 11 and 13 all dealt with central angles where they are equal to the arc. So kind of mix matching these 3 basic concepts together, allowing us to solve for various pieces. Okay, question number 15. All right, so before we get too lost in the circle, this shape in the center is in fact a triangle. And we know that the triangle sum theorem states that if I added up all the angles, 45 plus 73 plus this x degrees, it should be equal to 180 degrees. So solving that down then lets me know that my x degree is equal to 62. So I know this is actually 62 degrees. Well, how does that actually help us? Well, once again, this is an angle that is on the circle. So if I extend this again, I'll actually do this in a different color. I'll extend it in black here. If I extend this angle all the way to the arc that it intercepts, that is in fact this unknown value of PQ. Well, the arc that we are looking for is equal to 2 times whatever the angle measure is going to be. Angle is equal to half the arc is equal to twice the angle. So this is, if this was 62 degrees, we simply need to multiply that by 2, which gives me my arc measure PQ is equal to 124 degrees. Question number 16, once again we see a triangle. We are looking for this angle measure, but a little different this time. I don't know the other 2 angles in my triangle. Instead, I'm given 2 other arc measures. Well, once again, we know that there are 360 degrees inside of a circle. So if I took 360 degrees minus this 144 and this 60 degrees, which are here and here, that would give me my remaining arc measure there. So that would give me a value of 156 degrees. Well, how does this arc relate to this angle that we're looking for? Well, this angle is once again on the circle. So if I were to go ahead and extend it all the way out to where it hits the arc, I would know that this angle measure is half of the arc. The angle measure is equal to half of the arc that it intercepts. Once again, the same relationship we were talking about in question number 15. The arc is twice the angle is half the arc. So if we know our arc is equal to 156, we just simply need to take half of 156 to figure out my angle measure. So in this case, angle EGF is equal to 78 degrees. Okay, last two questions. We're looking for two different pieces here, angle KBL and MBL, and here we're looking for arc CN, and this is a little typo. This should actually say measure of CBN. This unknown right there. All right, let's go back to number 17. We're looking for two different pieces here. I'm going to focus on this first, my question mark, because this looks like we're finding an angle on the inside of a circle. So we're inside of a circle. This angle is actually equal to this angle because they are vertical angles. So we're called into question of which arc should I actually use, this 140 or this 70 idea. Well, since we are inside the circle, specifically looking for an angle or dealing with an angle inside, we know the formula of an angle is equal to 1/2 of me adding my arcs together. Arc plus arc. So filling in the relative information, we don't actually know what the angle is equal to, but we know what? We know the two arcs. So we would do 140 plus my 70. Simplifying that down gives me an angle measure equal to 105. So angle KBL is equal to 105 degrees. Well, that's great that this is 105, which I'll write in here. And this is also 105. That's great. How do we actually figure out what this angle is going to be? Well, if we recall, and I zoom in this a little bit more, here is this crosshairs in the center. We know that this is equal to 105. We know that this is also equal to 105 via vertical angles. How is this x degree and the 105 related? Well, together they form a straight line, or they are, in fact, you guessed it, supplementary, which means they add to 180 degrees. So that means then that 105 plus x should equal 180 degrees. So that means that x is equal to 75 degrees. My unknown angle, MBL, is 75 degrees. So here we see that we are using a formula from this particular chapter, helps us find an angle measure, and then we're doing a throwback to supplementary angles, linear pairs not going away, to find our other missing. Okay, question number 18, we're going to find arc CN. To start with, well, how is this arc CN related? Well, the only given information here is angle 39. And we can see that this angle sits on the circle, so this angle is going to be equal to half of whatever arc it intercepts. If I extend this over, hey, this angle is half of whatever this measure is, or the reverse of that. My arc is equal to 2 times whatever my angle measure is going to be. So that means 2 times my 39 degrees gives me that this arc CN is equal to 78 degrees. Wonderful, 78 degrees. All right, well, how does this 78 and this 39 help me find this x degrees, or angle CBN? Well, this angle, angle x or angle CBN, is also on the circle. So let's go ahead and extend this out to the arc that it intercepts. And it intercepts this arc, CN. Wait a minute, it intercepts the same arc. So I know that this angle measure is equal to 1/2 of the arc that it intercepts. So that means then if I just simply need to take half of the arc measure, which was 78, which gives me that angle CBN is actually equal to 39 degrees. And that kind of makes sense. These two angles, which are on the circle, both intercept the same arc, so it makes sense that they would be half of the same value. This would be 39, and this would also be 39. Once again, if we're trying to look at this in terms of pieces, this section should be 39, this arc and this angle relationship, but it's also the same idea if I were to go from here. Actually, let me undo that. We were to go from here to here. That's also the same relationship, arc to angle measure. We should get the same answer.